First of all, let me introduce myself. My name is Julia Bragina. I'm Environment, Health and Safety Manager at Schneider Electric in Russia. Also, I'm a leader of the Green Team. It's our group of environmental volunteers in our company. Also, I'm a leader of the Green. Oh, sorry, I have sound. I'd like today to share with you my experience in the environmental field, and I think that this information can be useful for you in your project in this challenge. I will tell you about the circular economy principles. Let's move to the first slide. I'd like to start my presentation today with the Sustainable Development Goals. I think maybe you have heard about them. The Sustainable Development Goals were created in 2015. Their aim is to end poverty, protect the planet, ensure peaceful and prosperous lives for all us. We can divide all these goals into three types: social, environmental, and economical. I will tell you today about our environmental goals, and if you know, the scientific group proposed the special day. Its name's Overshoot Day. This day marks the date when humanity's demand for ecological resources and services in a given year exceeds what Earth can regenerate in that year. Earth Overshoot Day is hosted and calculated by the Global Footprint Network. It's an international research organization that provides decision makers with a menu of tools to help the human economy operate with the Earth's ecological limits. The concept was developed in 2006. Since then, the date of Earth Overshoot Date has been calculated each year, going from 1961. The base year you can see here, it's 1970. At this year, we think that our ecological resources, which we are using through the year in this year, in 1 year, it's one Earth. But you can see that every year after 1970, our consumption of ecological resources is increasing. And this trend you can see all last 20, 30 years. But in 2020, the coronavirus and used lockdowns caused the global ecological footprint to contract almost 10%. But we still use as many ecological resources as if we lived on 1.6 Earths. It means that by the 22nd of August, we will have harvested more trees than forests can renew. caught more fish than the ocean can replenish and emitted more carbon dioxide into the atmosphere than ecosystems can absorb over the entire year. The Global Footprint Network proposed the special flash mob. It names Move the Date. The ultimate goal is to move the date of Earth Overshoot Day back to the 31st of December or beyond by driving resources efficiency while improving humanity's well-being. The move the date can stop at Earth Overshoot Day, and we need to keep growing the movement throughout the year. At this slide, you can see different actions which can move the date for several days. In the middle, you can see that we can move the date more than 3 months if we will reduce the carbon component of humanity's ecological footprint for 15%. And if we will cut food waste in half, we can move the date for 13 days. Let's move to the next slide. I think that we need to explain the different types of economy. We will start with the traditional type of economy before we will move to the circle economy. The traditional type is a linear economy. Linear economy traditionally follow the take, make, and dispose principles. This means that raw materials are collected and then transformed into products that are used until they are finally discarded as waste. You can see two different cycles, natural and technical. Natural cycle is sustainable, but the technical cycle in the linear economy ends in the landfill. A traditional economic paradigm is characterized by two unsustainable processes, resources scarcity and excessive pollution load. Both cause ecosystem degradation, wealth concentration, and social inequities. And like the result, this linear economy ends at the landfill. High prices, sustained economic growth, urbanization, population growth, growing shortage of raw materials and energy resources, increasing environmental pollution, including greenhouse gas emissions, rising temperatures, climate change, the growth of areas occupied by landfills, pushed business to and scientific community to rethink the way of the traditional economic model. Every year, humans consume more and more resources. And in this context, we all need to rethink the way we consume resources. We have to adopt the circular principles such as repair, reuse, refurbish, remanufacture, and recycle. And now we can start with the circle economy. You can see the same picture, but it's not similar to the first one, to the picture of the linear economy. The technical cycle in the circle economy is sustainable, like in the natural cycle. Circle economy is an alternative to a traditional linear economy, in which we keep resources in use for as long as possible, and we extract the maximum value from them whilst in use. Then recover and regenerate products and materials at the end of each service life. A circular economy seeks to rebuild capital, whether this is financial, manufactured, human, social, or natural. This ensures enhanced flows and of goods and services. Let's move to the circle diagram. At this slide, you can see various loops of circular economy. At the left side, you can see the loops of biological materials, and at the right side, the technical materials. The technical materials, they can move at this circle and different stages, such as maintains, reuse, refurbish, and recycle. And only after the last stage is recycle, the product which is not used can be devised to the different parts and go back to the circle of this circle economy model. As for biological materials, you can see the biocycle. I think that the biocycle for you will be more useful in your designing of the greenhouse, because you have to prevent some measures. You have to prevent the waste management in your greenhouse, because it should be the greenhouse in the city and the town, and you have to understand where different parts which will not in the use will be recycling, or how you will put it again in the circle. And I will explain you these loops. The biocycle of the circular economy: organic matter free of toxic contaminants gradually break down, cascading through different value extracting stages before returning safely to the soil. The biocycle economy harvests over 13 billion tons of biomass globally to use as food, energy, and raw materials. The organic waste is traditionally seen as a costly problem in economic and environmental terms. The equation can be reversed by designing more effective recovery and processing systems to turn organic waste into a source of value and contributing to the restoration of natural capital. You can see here the anaerobic digestion. Anaerobic digestion is the most widely adopted technology in this area and can be applied to a wide range of organic materials to generate biogas, leaving a nutrient-rich substance called digestate. The biogas can either be upgraded to biomethane biogas. It can be adopted by biomethane and renewable liquid CO2, or converted to renewable baseload electricity using conventional thermal power processes. The biomethane can be fed to the gas grid and contribute to decarbonization of process heat or be compressed to use as a transport fuel for over 80% CO2 savings compared to diesel. This is one ideal and technology-ready way to decarbonize our heavy vehicle fleet. This digistate has various benefits. Add carbon to the soil, creating an opportunity for carbon farming or negative carbon agriculture by sequestering carbon into the soil. The nitrogen is more available than synthetic fertilizers and manures. Displacing 1 ton of artificial fertilizer saves 108 tons of water, 1 ton of oil, and 8 tons of carbon dioxide in the process. Let's move to the next slide. You can see the 3 main principles of the circular economy. For these principles you can use for the biomaterials and technical materials. They are design out waste and pollution, keep products and materials in use, and regenerate natural systems. This circular economy model not only corresponds to the global goals of individual countries or of the individual companies, but also directly related to the goals of sustainable development goals, such as, you can see them, responsible consumption and production, affordable clean energy, sustainable cities and communities, climate action, life below water, life on land. There are 5 business models of the circular economy. They are circular suppliers, resource recovery, product life extension, sharing platforms, a product as a service. You can maybe do some examples. For example, for sharing platforms, like example can be BlaBlaCar or Yandex Drive platform. For product and service, I can make the example with our company, and I will explain you later what is the type, what we are doing in our company. At Schneider Electric, we have the circle principles in our production, and we have the circular economy like a part of our environmental strategy and the strategy on sustainability. These circle principles give the opportunities for our customers, such as less energy consumption, less water consumption, CO2 emissions, and decreasing. And in different ways, we are using the circular principles. We have the materials circularity, like special eco-design of our products, product circularity. We have the special services for our customers. And we have a value proposition. We propose in the energy management like a service. If the company want to decrease the consumption of electricity, for example. And we are using the circular principles in the sustainable is in our supply chain. We checking our raw material. We have special programs for the waste recovery, and we are reusing the packaging and trying to minimize it. Let's continue with the biocycle. I think that when you are designing your greenhouse, you have to think about such things as the waste management. Maybe you was thinking what type of waste can be as a result of the functioning of the of this greenhouse. I think that the most part of the waste, it will be the biological material, such as leaves, some wooden chips, etc. And that's why I'd like to present you some information about the composting process. There are different types. Each composting method has its advantages and disadvantages, depending on where you want to compost, how much space you have available, the amount of compost you would like to make, cost of buying or making the composter, and the time you have available to maintain your compost. We will start with the open windrow composting. It's used for processing garden waste such as grass cuttings, pruning, and leaves, either on an open air or covered areas. It's you can see it's this type of composting is can be used for large amount of free space at your site. The next one is anaerobic digestion. I just told about it when I was explaining the biological cycle. This is a very good type for the not only for plant waste but also for wood waste and animal waste. The process happens in the absence of the oxygen in the oxygen-free tanks called anaerobic digester. And I don't know how what will be the size of your greenhouses, but I think if it will be not so big, you have to prevent maybe the composters for household amount of waste. And the most easy type is outdoor compost heap. The outdoor compost heap you can make by yourself. It can be made from the cheap materials such as wooden pellets or sheet metal. This method is better suited to garden where there is a generous amount of space for compost in and where a large amount of compost is useful. Small gaps, you can see small gaps in the side of the compost bin help aerate the decomposing organic matter, but also allows some heat to escape. The compost bin should be not very big. It's only 1 square meter and 1 meter high. Now I'd like you to present the plastic type of composters. We will start with the outdoor compost bin. Outdoor compost bin is convenient if you have only a small space, and they're usually made of plastic with dark colors. These darker colors help to absorb heat and speed up the decomposition. The next type is outdoor hot compost bin. It's the second one. They allow decomposition to happen at a much faster rate by increasing the temperature by the decomposing matter. The resulting compost is thinner than when produced without the other methods. The last one, it's a vermicomposter. It's have different levels with the worms you can see here. Vermicomposter is perfect for the small scale indoor or outdoor composting. The worms aerate and break down the decomposing organic matter quickly and produce a nutrient-rich liquid fertilizer called leachate or worm tea. It can be in the outdoor and inside. I think that it will be a very interesting example for you. I know that in this challenge there are different teams from different countries, cities, and if you will be in Moscow, I'd like to advise you to visit the Botanical Garden of Moscow State University. Its name's Aptekarski Огород. And this botanical garden is one of the oldest scientific botanical institutions in Russia. It is widely known in Russia for its scientific and educational activities, and more than 6,000 species of plants planted at its territory. You can see at this photo, for example, different greenhouses with different plants. And at 2019, the Botanical Garden has presented the special zone with the composting biocycle. The main principles of this garden are to avoid the usage of the mineral fertilizers and not to take plant residues outside the garden, and if it's possible, to transform them into useful substances such as compost, mulch, wood chips, fallen leaves. The key technologies in the process are shredding, composting, vermicomposting. At this site, all these processes are presented in action, and you can visit this garden and see it by yourself. There are some pictures from these zones, and I advise you to do it if you will be in Moscow. And I think it's a very good idea to share this experience with people, because some of them can use this experience in their own gardens, and some ecological projects, for example. The next slide is about the waste recovery in Russia. I think that the participants in this challenge who are living in Russia, you know that we have some problems with this waste recovery in different regions, but according to the statistic information, we have more than 1,600 waste recycling companies in Russia, and most part of them is loaded by raw materials only for 20 and 40%, and forced to buy raw materials abroad. The region where you have to present these greenhouses is in the Siberia, and it's Tomsk region. And if in Moscow or in St. Petersburg, the situation with the waste recycling is not so difficult, in Siberia, we have some difficulties with the recycling, with the separating of waste. And I think that your project have to prevent the waste recycling, have to have to find the companies, active companies, which can take the different type of waste. I found some information. There are two companies. The first of them is Chistemir. This company accepts various garbage like plastic, glass, paper, and aluminium. This is the classic type of wastes from the households, and another one is Eco-Architectura. This company accepts 14 types of waste, including fluorescent and mercury-containing lamps. I know that in the greenhouses, we can use in your project this type of lamps. And I want you to know that the fluorescent lamp, this is the hazardous waste, which is classified in Russia like a first class waste. And you have to have the special contract, the special agreement with the company which can do the demercurization, and not to take these lamps to the landfill, because it's can be very dangerous for the environment in this region. This is, I think, this is the all my presentation. I'd like to read your questions if you have. I will look at the chat, and if you'll have some questions, I will answer them. You can do some questions in the chat, and if you will do it, I can answer later or now. Okay. Okay, if we will have some questions in the future, also I will be glad to answer them. And I have to wish you a good day and to have success in this challenge. Thank you very much. I think that we will stop this presentation.